morning, dear student. Welcome to you e-learning class managed by Modern English School Nawada. Dear student, myself Sujay Kumar, your mathematics teacher of Modern English School, New Area now. Student, today I start the new part of the mensuration, and this part is the volume and surface area of the solids of exercise 17. So today I discuss how to write the formula of the volume and surface area of different types of the shape of the solids, and then some examples of the exercise 17. So please pay attention to watch the boards. Here is the first exercise, that is volume and surface area of the solids. Starting at Q, it is a solid figure whose all six faces are in the form of a square. All the six faces are in the form of a square, and each side have equal length. It is A, then all part is A. So first write what is the curved surface area, otherwise you can say lateral surface area, otherwise you can say area of 4 bar. Area of 4 bar. It is equal to 4A square. It is the curved surface area, that is lateral surface area, and the area of 4 bar, then it is equal to 4A square. Then total surface area, here is total surface area, it is equal to 6A square, and volume of this figure is A cube, and diagonal of the cube is equal to, it is the cube, the cube is root 3 into A. Similarly, when your question is related to cuboid, that is cuboid will form in rectangle form, and it is upper and lower part of the seam. It is in the form like a brick duster. It is the form of the cuboid. It has three-dimensional figure, that is length, it is breadth, and it is height. So it has also three formula, that is what is the CSA, lateral surface and area of 4 bar, it is equal to 2 into L plus B into H. It is the area of 4 bar. It is also called lateral surface area of cuboid, CUBOID. This is the lateral surface area of cuboid, that is 2 into L plus B into H. Total surface area is equal to 2 into LB plus BH and plus LH. And last, volume is equal to length into breadth into height, and diagonal is equal to under root L square, B square and H square. This is under root. It is the diagonal. So CSA is equal to lateral surface area and is equal to area of 4 bar. It is equal to 2 into L plus B into H. Total surface area, it is equal to 2 into LB plus BH into LH. And last, volume, that is length into breadth into height, and then the diagonal, it is equal to L square plus B square plus H square. It is the part of the cuboid. After that, you find the sum formula of the cylinder. A plain paper, folding, rolling it about its length and breadth, then it is form a solid figure, and it is called a cylinder. It is also called right circular cylinder. It has two dimensions. Here is height and here is radius. Two things is given, but figure is a three-dimensional. So one is height, that is called vertical height, and it is the radius. There is also what is the volume cylinder, CYLINDER. It is cylinder. So what is the volume of the cylinder? And volume is equal to pi r square h, because area of this part is the work is a circle and total is height. So area of this is pi r square multiply into h, that is pi r square h. It is the volume of the cylinder. CSA of the cylinder, that is curved surface area of cylinder, it is equal to 2 pi r h. 2 pi r is the circumference of the circle, and it is multiplied by h, that is CSA of the circle is 2 pi RH. And third, total surface Third is total surface area. It is equal to 2 pi rh plus 2 pi r square. Then it is equal to 2 pi r h plus r. It is the area volume of the cylinder. It is the surface area of the cylinder, and it is the total surface area of the cylinder. Then one is pi r square h, second is 2 pi r h, and third is 2 pi r h plus 2 pi r square, that is 2 pi r h plus r. After that, you have to find about the cone. Cone, like as birthday cake, it is found like as here as a key. Here two heights. One is called vertical height. AB is the called vertical height, and AC is the called slant height. This slant height is denoted by L. This radius is denoted by R, and vertical height is denoted by H. So first use the Pythagoras theorem. You can find L. It is equal to H square plus R square under root. L is the work is the hypotenuse. So L is equal to H square plus R square. In this figure, H is the work is the perpendicular. Then what is H? It is equal to L square minus R square. What is R? It is equal to L square minus H square. After that, what is the CSC of the cone? CSC of the cone is equal to pi RL. What is the total surface area of the cone? It is equal to pi RL plus pi R square. Here is pi R common, then you get here is L plus R. It is the CSA and there is TSA, and last volume. It is the 1/3 of the cylinder, that is 1/3 pi R square H. And lastly, you have to find a sphere and hemisphere. A sphere like a football, and half of the football is hemisphere. Then it is a three-dimensional figure, but it is like a circle on the board. It is R. Here is CSA and SC and TSC, all are the same because it's all part of the curve. So it is curved surface area. It is also called like total surface area and also surface area. It is equal to 4 pi R square. And next volume, and volume is equal to 4 by 3 pi R cube. And next is figure is hemisphere, like a ball. Its radius is always equal to the height. So radius of hemisphere is always equal to the height of the hemisphere. So CSC of hemisphere is equal to 2 pi R square. It is 4 pi square, and this is the hemisphere CSA. This is 2 pi R square, and TSA is equal to 3 pi R square. Because 1 pi R square is increased, it is in the part of the circle. It is 2 pi R square and 1 pi R square is the circle, that is 3 pi R square. And last is volume. Volume is 2 by 3 pi R cube. It is the volume of the figure. So one is, what is the surface area of the sphere? That is 4 pi square. Volume of a sphere 4 by 3 pi R cube. It is hemisphere. It is 2 pi R square of CSA. It is TSA, that is 3 pi R square. Volume of hemisphere is 2 by 3 pi R cube. And now discuss some examples of exercise 17a. So now see some problem related to these questions of example second, exercise 17a. A sphere and a cube have equal surface area, so that the ratio of the volume of a sphere to the cube is √6 is to √5. Here is given in your question that a sphere and a cube have equal surface area. The sphere is equal to 4 pi R square surface area, and cube surface area is 6a square. So your question is, what is the ratio of the volume of a sphere to the cube? From this equation, you can find the value of r and also you can find the value of a. So dear students, first we find what is the value of a square. It is equal to 4 pi r square by 6. It is 2 and it is 3. After that, what is the value of a? That is under root 2 pi r square by 3. Then it is equal to 2 pi by 3 r. Because r is the square, so it is 2 by 3 pi. Your question, what is the volume of a sphere to the cube? So volume of a sphere to the volume of cube. What is it? Its formula volume of a sphere is 4 by 3 pi r cube, and volume of cube is the formula a cube. So now we write here that it is 4 by 3 pi r cube, and when you write the cube of this, then you write here 2 pi by 3 r under root cube. Then what you get here? Now you see here, you get here it is equal 4 pi r cube by 3 divided, here is the cube because a cube, so you write here 2 pi by 3 into r cube, and one is under root 2 pi by 3. How it is possible? If cube 2 times it is 2 pi by 3 and one root is remain and cube is r cube. So r cube is k. Now see that you have to ratio 4 pi r cube by under root 2 pi r 3 to the power 3. Then here is 4 pi r cube by 3 and here is 2 pi 3 r cube. Then r cube cancel, 2 pi cancel, here is 3 and 3, here is 2 pi by 3 under root remain. This 3 go in the upper part, that is root 3, and this root 2 cancel 2 by root 2. Then root 2 into root 3, that is root 6, and here is root 5, then here is root 5. So the answer will be root 6 is to root 5. It is your solution. Now see question number example 5. Very important for board examinations, for 4 marks of the questions. This is a cylindrical tub of radius 5 cm. It is a cylindrical tub with radius 5 cm and length is 9.8 cm. Length means height, and height of this cylindrical tub is 9.8 cm. Is full of water. It is full of the water. A solid in the form of right circular cone. A solid in the form of right circular cone mounted on a hemisphere. It is right circular cone and it is mounted on a hemisphere. Is 3 cm of radius and total height of the solid is 8.5 cm. Then your question is find the volume of the left water in the tank. So first you write what is the volume of the water of this tank. So then volume of the water, it is in the form of a cylinder. So there is no any formula of the volume of the water. It depends on the size and the shape of the vessel. The vessel in the form of cylinder. Then your question is what is the volume of the water? That means your question is what is the volume of the cylinder. So it is equal to pi r square h. Then here is pi r is given, that is 5 into 5 and 9.8. It is height. So we write here 10. Then 5 2 is 10 and 2 49 is, then 49 into 5, then 9 5 is 45 and 5 4 is 20, that is 245 pi centimeter cube. it is the volume of the whole cylinder that it contains the water. It is the total volume of the cylinder. After that, what is the volume of this solid? Volume of the solid, volume of the solids. This is equal to the 2 by 3 pi r cube. It is the volume of the cylinder, and plus 1 by 3 pi r square h. It is the volume of the cone. So here is 1 by 3 pi r square as common, because radius of both part are the same, because here is the hemisphere and there is the cone, but on the same base and radius will be same. So both are, if take common, 1 by 3 pi r square, then here is 2r and here is 3 common, then here is remain pi r square common, then 1 dx. So what is the radius? That is 1 by 3 pi. The radius is given, it is 3.5, that is 3.5 square, and 2r, that is 2 into 3.5 and plus h. So what is h? It is 3.5 and here is total 3.5 or total is 8.5, the remainder is 5. So radius is 5, height is 5. So what you get here? 1 by 3 5 into 3.5 square, and it is equal to 7 plus 5, that is 12. So it is equal to 1 by 3 into pi into 3.5 into 3.5 into 12. So this point cancel, you write 10, 10. Then 5 7 ja, 5 2 ja, 5 7 ja, 5 2 ja, and 3 4 ja, and these 2 cancel and 2 cancel. So you have only 49 centimeters. So your dear student, it is given that the volume of water in this vessel, whose radius is 5 cm and height is 9.8 cm, is the volume is 245 cm cube. And after that, when you find what is the volume of the solid, that is 2 by 3 pi r cube plus 1 by 3 pi r square h. Here you take common 1 by 3 pi r square, then here is remain 2r plus h. Then 1 by 3 pi, r is 3.5 square, 2r, then r is 3.5, that is 2 into 3.5 plus 5, that is 7 plus 5. So what you get? 1 by 3 pi into 3.5 by 10, 3.5 by 10 into 12. So 3 4 ja 12 cancel, 7 5 5 2 7 ja 5 2 ja 5 7 ja 5 2 ja 2 2 ja 4 cancel, and 3 4 ja 12 cancel. So 7 7 ja 49. So what is the remaining part of the volume? So you subtract 245 minus 49, then you get 15, 9, that is 6. Here is 3, 13 4 9, and here is 1, 196 5 centimeter cube. It is the answer, that is remaining part of the volume, remain water in the vessels. Otherwise, you can write the value of pi, then you will get your solutions. That's all. So dear students, the remaining part of the examples of exercise 17a, try to solve by yourself. If you have any problem, then ask to me. Thank you, students.